We're going to do some basic post-processing this session, and people have expressed some interest in seeing a more advanced post-processing session in a later coffee break. We'll start here. It is just a beam model. It has these three-dimensional elements in it, and it's constrained at one end, and there is a 20-unit applied load in the other end. Right now, we are still in HyperMesh. This is what we've been looking at throughout this series, but we're going to want to do our post-processing in HyperView. With this new interface, the goal is to integrate these things as much as possible, and you'll see it is still definitely a work in progress, but still usable to get the functionality. If we want to be able to open a session of HyperView side by side, maybe to compare different things or look at the original model, we have this drop down here that allows us to split the window. So I'm just going to split this into two sessions. Whatever session is active will be highlighted in blue. You can click over and highlight this other session. That will make that the active session. You'll notice that it switches over to HyperView, and now I have post-processing options up in the top ribbon instead of pre-processing options. So I will load the input and the results file for this model. And hit apply. And rather than continuing to work in this, I'm just going to maximize this so it takes up the whole screen. But at any point, we can return to this multi-window option. All right, over here we have our Model Explorer. If we have any other load steps in here, they'll show up in the drop-down menu. And if we have different increments, maybe we're running a nonlinear analysis, we'll have the different time or steps, the load steps in here. I personally like to look at this with the mesh lines on, especially so you can look at individual elements, but there's different visualizations. And we're going to just orient this. The first thing I think most of us like to do is to just play this, make sure the animation that comes out of this seems reasonable compared to the loads applied. This play button here, that plays really fast. Maybe we want to slow that down, look at something that doesn't give us a seizure. We have this more normal speed animation. There are also different animation modes depending on what kind of analysis you're looking at. So interpolation, that's what we'll use. We're just interpolating from the first to the last step because it's linear. But if we had other steps, we could switch it to transient or switch it over to modal. Other things we might want to do in basic post-processing, being able to contour results. You'll notice that it takes you to the panel. This is not the long-term plan here. The long-term plan will be to have the nice icons here. But for now, in this model, we have displacement results, reaction forces, and some stress results. So for displacement, we can either plot the magnitude or X, Y, and Z components. The load is in Y. Let's go ahead and look at the displacement in Y. And we can either animate or go ahead and just switch to the final result. One thing, if the animation and the displacements are relatively small and difficult to see, we can always scale the deformation, not the contour, just the visualization of the results. So maybe I want to scale these by a factor of 10, and I can see now for some of those smaller displacements, something that's easier to visualize. Back to the contour plot, we can plot different stresses. So let's say we want to plot stress in the X direction. And if we want to, we can interpolate those results out to the corners. But for now, we're just going to take them in the element centroid. As we would expect, given what's happening with the bending in this beam, we have these positive results for stress and tension at the top and negative results at the bottom. For a more complex model, perhaps they'd want to see interior stresses, so not just what's happening on the outside of this solid model, but being able to make a section cut. You'll notice it just makes a section cut right away, kind of arbitrarily, but we can change this XYZ. You can also use this to define your own plane to cut along. But once you're in the section cut, you can just click and drag in order to change where the section plane is cutting. We can also do this, for instance, in Y and see the interior that way. We can delete this, get out of it, or you can keep it on and do some other stuff with the section cut on. Other useful tools in here are the ability to create derived results. So maybe I have my own special formulation to determine failure in my beam. So I will call this my failure, and I'm purely making up this result. But let's say I want to subtract stress in X and then take away stress in Y. And based on other kind of stress formulations I might want to build, let's say I want to raise this and square it. So just an idea of some of the functions you can put in here. For now, we're going to click OK. And now when we go to the contour, we'll have this and we can contour our results to be whatever custom failure criteria or just numeric value that we want to contour. All right, other interesting things in here, matrix browser, especially if we want to get results out and maybe do some further post-processing in a spreadsheet. It has not been officially designated a spot on here. If we control X, we'll look for matrix browser. We do have to load, kind of oddly for now, it's grouped in the aerospace tools because that was the original users of this. So we'll say load reference file. You'll choose the aerospace tools, and now we should be able to also not find the matrix browser. Let me see if we can get it in pre-processing just to show kind of the utility of this tool. There we go. All right, so this actually, if you see here, it can be used in pre or post to do mass updates. Here I'm going to try and use it to just extract results. So right now, in order to get entities from the model in this HyperView tool, you'll have to have a HyperMesh entity to pull that original model data from, just kind of an interesting quirk for the moment. From here, I can select what nodes, and I'm just going to request the reaction forces from this face. So I'll do by face as my selection method, select all of these, and they will populate the nodes here. We will select these nodes and ask for instead HyperView data, so results data now. I'm going to ask for the current subcase, and we can ask for instance, the reaction forces in Y. Hit query. I want why this beam is aligned in the global system, so I can ask for global results. And now I have for each node quickly the reaction forces pulled. Long term, you will be able to add your own functions and such, create a macro, and automatically have this generate on any model, not just this beam model. It can be generalized. You'll just select new elements or nodes for whatever you're working on. This utility here is being able to just direct link this to Excel and do some post-processing. So maybe I want to check to make sure that my reaction forces total that 20 units that I've applied. So I will sum this, and I get 19.9, well within a rounding error of 20. If I wanted to, I could do some more calculations, actually bring this back. You just click the matrix button to auto-populate with everything you've done in Excel, and then you could actually contour anything that you've done here as well onto your contour in HyperView. Let me make sure I've got everything I wanted to cover. Oh yes, I do have one more thing. Unfortunately, I wasn't able to get it in the Abacus deck, so I'm just going to show it quickly. With the OptiStruct model, I just went ahead and added an additional load case to this. Mention a new, and I'll just switch over. You can switch over to any of these HyperWorks tools within this same framework. We'll go to HyperView and we will open a model. And this is that same B model. It has the 20 unit load applied to it. The only difference in this case is that I've also got a second subcase, and that is going to be just a moment that I've also applied to the tip of this beam. So we can switch here. We can animate this. This is actually the direction that I wanted. So we can go in and contour anything we could for the first load case, but what I really wanted to show here is the ability to make an envelopes from these. So we could just add them together as if they were happening at the same time, but perhaps more useful, especially if we have a lot of different subcases and we're trying to narrow our focus or see what's affecting our model the most, we can put these subcases in an envelope. Now you have your derived load case that shows up as something you can contour. And this allows me to say, what is the maximum stress in my beam across all the load cases? I actually have basically like a function here just asking for the maximum on each element. Perhaps useful in and of itself, but personally I know quite a few customers who like the subcase option. So maybe they have 10 load cases here. They want to narrow this down to 3 to perform an optimization. So we can apply here and just on this basic color coding see that for the majority of our elements, what would drive the results here and drive our design is actually subcase 4 for potentially more of these elements than subcase 3. But again, the more load cases you have, I think the more this tool can come in handy.